Mars, the red planet, has captivated humanity for centuries. Its mysterious allure has been a source of inspiration for astronomers, scientists, and dreamers alike. Its rusty red hue, visible even to the naked eye, has sparked countless tales of alien life and interplanetary adventures. From ancient mythology to modern science fiction, Mars has always been a symbol of the unknown and the possibility of life beyond Earth. Today, Mars stands as the next great frontier in space exploration, a potential second home for humankind. With missions from various space agencies, the dream of setting foot on Mars is closer than ever before. But making Mars habitable is a challenge. The planet's harsh environment, with its extreme temperatures and frequent dust storms, poses significant obstacles. One of the biggest hurdles Mars is leaking its atmosphere into space. This thin atmosphere, which is crucial for sustaining life, is gradually being stripped away. This leakage is more intense at certain points in Mars's orbit. As Mars moves closer to the Sun, the solar wind's impact becomes more pronounced, accelerating the loss of its atmosphere. Understanding why this happens is crucial for planning future missions and potentially terraforming the red planet. Scientists are working tirelessly to uncover the mysteries of Mars's atmospheric loss. The answer lies in the interplay between Mars's elliptical orbit, the Sun's powerful solar wind, and the composition of Mars's thin atmosphere. By studying these factors, we can develop strategies to protect and perhaps even restore Mars's atmosphere, bringing us one step closer to making the red planet a viable home for future generations. Unlike Earth, which has a nearly circular orbit, Mars travels around the Sun in an ellipse. This means that Mars's distance from the Sun varies significantly throughout its year. At its closest point, called perihelion, Mars is bombarded with significantly more solar energy. At its furthest point, aphelion, the red planet, receives far less warmth. These extreme temperature swings, combined with Mars's thin atmosphere, make the planet a hostile environment. But the elliptical orbit has another, less obvious effect. It influences how quickly Mars loses its atmosphere to space. The Sun constantly emits a stream of charged particles called the solar wind. This wind, composed mostly of protons and electrons, travels at incredible speeds, carrying with it the Sun's magnetic field. On Earth, our planet's strong magnetic field acts as a shield, deflecting most of the solar wind and protecting our atmosphere. Mars, however, lacks a global magnetic field. This leaves its atmosphere directly exposed to the brunt of the solar wind. While Mars does have a weak, induced magnetic field, it is not strong enough to provide substantial protection. Mars's atmosphere is about 100 times thinner than Earth's, composed mainly of carbon dioxide with small amounts of nitrogen and argon. This thin atmosphere provides little resistance to the solar wind, allowing it to strip away atmospheric gases into space. Think of it like blowing on a dandelion. The force of your breath easily carries away the delicate seeds. This process, known as atmospheric escape, happens constantly. However, the rate of escape increases dramatically when Mars is closer to the Sun. This is where the elliptical orbit plays a crucial role. Section 5. A Tale of Escaping Gas. As Mars reaches perihelion, the Sun's heat and radiation intensify significantly, bathing the planet in a surge of solar energy. This increased solar energy provides more energy to the atoms and molecules in Mars's upper atmosphere, causing them to become highly energized. Some of these energized particles gain enough speed to escape Mars's weak gravitational pull and are carried away by the solar wind, a stream of charged particles emanating from the Sun. This escape process is not uniform across the planet. Different regions and altitudes experience varying rates of atmospheric loss. Observations have shown that Mars actually develops a faint tail of escaping atmospheric gases, much like a comet's tail, that points away from the Sun. This tail is composed of particles that have been stripped away by the solar wind. This tail is most prominent when Mars is closest to the Sun, highlighting the increased rate of atmospheric loss at perihelion. During this time, the interaction between Mars's atmosphere and the solar wind is at its peak, leading to a more noticeable tail. Section 6. MAVEN's Revelations. NASA's MAVEN, or Mars Atmosphere and Volatile Evolution spacecraft, launched in 2013, has been instrumental in studying this phenomenon. Orbiting Mars and dipping into its upper atmosphere, MAVEN has provided unprecedented details about how the solar wind interacts with and strips away Mars's atmosphere. MAVEN's data confirmed that atmospheric escape increases significantly when Mars is closer to the Sun. The spacecraft also revealed that the escaping gases include not just lighter elements like hydrogen, but also heavier elements like oxygen and carbon dioxide, essential components for any future terraforming efforts. Section 7. The future of Mars exploration. The ongoing escape of Mars's atmosphere has profound implications for future human missions. A thicker atmosphere would provide greater protection from harmful solar and cosmic radiation, enable the use of simpler landing systems for spacecraft, and even allow for liquid water to exist on the surface. Understanding how and why Mars loses its atmosphere is crucial for developing strategies to mitigate this loss. Potential solutions, though still in the realm of science fiction, include creating an artificial magnetic shield for Mars, or finding ways to thicken its atmosphere through engineered processes. Section 8. Conclusion. Protecting our Martian future. As we stand on the brink of a new era in space exploration, the importance of safeguarding our Martian future cannot be overstated. Mars's leaking atmosphere is a stark reminder of the challenges we face in our quest to explore and potentially colonize the red planet. The thin atmosphere, constantly being stripped away by solar winds, poses significant hurdles for sustaining human life and creating a habitable environment. By studying this phenomenon, we gain a deeper understanding of planetary evolution, the dynamics of the solar system, and the challenges and possibilities of making Mars a second home for humankind. This research not only informs our strategies for Mars, but also enhances our knowledge of Earth's own atmospheric processes and vulnerabilities. As we continue to explore Mars and unlock its secrets, one thing is clear: preserving and potentially restoring Mars's atmosphere will be crucial for realizing our Martian dreams. Innovative technologies and international collaboration will be key in developing solutions to protect and sustain the Martian environment. The red planet beckons, but it also reminds us that our journey into the cosmos requires careful consideration and a deep respect for the delicate balance of worlds beyond our own. Our efforts today will shape the future of interplanetary exploration and the legacy we leave for generations to come.